The vectors 7, negative 3, and 12, negative 5 are eigenvectors for the given 2 by 2 matrix. We're asked to determine the eigenvalue corresponding to the eigenvector 7, negative 3, as well as the eigenvalue corresponding to the vector 12, negative 5. The eigenvalue in the corresponding eigenvector must satisfy the equation matrix A times vector x equals lambda times vector x, where vector x is the eigenvector and lambda is the corresponding eigenvalue. To begin, we will determine matrix A times vector x, which is matrix A times the given eigenvector. I've already set this up to save time. The product is the vector negative 14, 6, which must equal lambda times vector x, where again vector x is a given eigenvector of 7, negative 3. So if we substitute the vector 7, negative 3 for x, notice the vector negative 14, 6 is a scalar multiple of the vector 7, negative 3, the eigenvector. And by inspection, we can probably determine that lambda is equal to negative 2, since the vector negative 14, 6 is equal to negative 2 times the vector 7, negative 3, which indicates the eigenvalue corresponding to the eigenvector 7, negative 3 is lambda equals negative 2. Now, if we can't determine lambda by inspection, we can always take this equation here and set up and solve an equation. We can form an equation using either corresponding elements. For example, if we use the second elements, we can form the equation 6 equals lambda times negative 3, or negative 3 lambda, divide both sides by negative 3, and get lambda equals negative 2. To find the eigenvalue corresponding to the eigenvector 12, negative 5, we will follow the same process. We first determine matrix A times vector x, which again I've already done to save time. This results in the vector 60, negative 25, which is equal to lambda times vector x. So now we'll substitute the eigenvector 12, negative 5 for vector x, and again recognize the vector 60, negative 25 is a scalar multiple of the vector 12, negative 5, and since the vector 60, negative 25 is equal to 5 times the vector 12, negative 5, the eigenvalue corresponding to the vector 12, negative 5 is positive 5. Or again, if we need to, we can set up an equation using the vector equation here where we have the vector 60, negative 25 equals lambda times the vector 12, negative 5. Again, we can select any corresponding elements in the two vectors and form an equation. If we use the first elements this time, we have the equation 60 equals lambda times 12, or 12 lambda, dividing both sides by 12, we get lambda equals 5. I hope you found this helpful.